We're going to take a look at a couple of IXL questions from the module in IXL Geometry N.8. This first question says quadrilateral Cdef is a rhombus, and what is the measure of angle DCE? So let's start by identifying what we've got here. When we're talking about a rhombus, we're talking about a very specific type of parallelogram. In the case of a rhombus, we have diagonals which bisect one another at a right angle or a 90-degree angle. They are perpendicular to one another. We also have that our diagonals bisect opposite angles. So what that means is that this angle, this part of angle E, is congruent to the second part of angle E. Since this is a parallelogram, it's also true that angle C, opposite angle E, has been bisected into two congruent halves. And if we were showing the diagonal going from D to F, not only would that make a 90-degree angle, but we would see the same exact thing has happened, that angle D has been bisected into two congruent halves, and angle F has been bisected as well into two congruent halves. So from this, we can actually label a couple of additional things. That angle that was 128 can be divided into two equal halves. This would be 64 each. That means that angle F, which was 128 degrees, was bisected into two congruent halves, also 64 and 64. Another feature of a parallelogram, or all quadrilaterals for that matter, is that the sum of all of the interior angles will be 360 degrees. If we subtract out our 128s, we can find out how many degrees are remaining inside this rhombus. We have 104 degrees remaining. Now, these 104 degrees are split up equally across vertices E and C. And since those vertices have been bisected, it's appropriate to take 104 degrees and divide it equally into four pieces. That means that each of our 52-degree angles at vertices E and C have been bisected into two 26-degree angles. Now let's look at our original question. It says, what is the measure of angle DCE? Well, angle DCE will be this angle right here, which happens to be one of our red angles at 26 degrees. Let's look at another one. It says quadrilateral GHIJ is a rhombus. Once again, all of those features we just examined with the previous question apply here. It says, what is the measure of angle FJG? So let's look really carefully at what angle that will be. FJG means that we're talking about this small angle right here. So I'm going to label it in red. Now let's take a look at the information we're given. We know that when we have a rhombus, the diagonals bisect one another at a right angle, or 90 degrees. We also know that the diagonals bisect opposite angles. That means this 29 degrees was part of a larger angle I. 29 and 29 meant that this was, at one time, a 58-degree angle that had been bisected. The same is true about the opposite angle G. It was 58 degrees, but it's been bisected into two equal halves, 29 degrees and 29 degrees. Now, the sum of all angles in a quadrilateral of any kind, whether it's a parallelogram, specifically a rhombus, rectangle, anything, is 360 degrees. If we subtract out the two 58-degree angles, we can find out what part remains for our other two vertices, H and J. We have 244 degrees remaining, which will be split up equally among vertices H and J. That makes 122 degrees each. The diagonals bisect each of those angles, and so we will split the 122 once again equally into two congruent halves, and that means each of these angles will be 61 degrees. 61 degrees and 61 degrees makes the 122, and opposite angles are congruent in all parallelograms. That means that angle FJG must be 61 degrees. Let's look at a third one. It says quadrilateral Bcde is a rhombus, same type of shape that we've been looking at for the last two examples. It says, what's the measure of angle ACB? Let's label that angle. ACB will be this part of the vertex angle C. I'm going to label it in red. Now let's go ahead and label the information that's given. We have 54 degrees, which was bisected from a larger angle, which must have been 108 degrees. Opposite angles are congruent in all parallelograms, so we can label those as well. If I have 108 degrees at each of my vertices D and B, let's find out how many degrees of my 360 are remaining. I have 144 degrees remaining, which I'll split up equally over vertices C and D, which they themselves will be bisected. So if I'd like to, I can go ahead and just divide by 4 here. That means the measure of ACB will be 36 degrees. Now you may be noticing a small pattern here. If you recall, one of the first properties that I cited regarding a rhombus is that the diagonals bisect one another at a right angle, or 90 degrees. You'll notice that we formed 4 triangles here, and that they are all right triangles. In other words, the base angle at vertex A is 90 degrees. That means that I have an additional 90 degrees to split up among my other 2 angles, since the sum of all 3 angles in a triangle must be 180 degrees. That means that we can actually solve these questions quite a bit more easily by thinking about them in terms of triangles. If I've got 90 degrees at vertex A, that means that I need to have an additional 90 degrees between 54 and the missing angle. Well, 54 plus 36 makes 90 degrees, and this works out on all of the examples that we've already looked at. Let's look back and take a look. 61 and 29 makes 90 degrees. Vertex angle F will also be 90 degrees. 90 and 90 makes 180. And back to that first example, 64 and 26 makes 90 degrees. The additional 90 degrees to complete the triangle is found here at the vertex in the center of the rhombus. Let's go back to that last example, example number 4, and let's use that property to solve this time. It says quadrilateral GHIJ is a rhombus. What's the measure of angle FIH? Let's go ahead and label that angle. FIH means that we're interested in this part of the vertex angle I. Once again, we're told that we're looking at a rhombus. Remember that with a rhombus, diagonals bisect one another at a right angle. I also know that diagonals bisect opposite angles, so I'll go ahead and label the additional angles that I know for this particular rhombus. This time I'm going to highlight in red the right triangle that we are interested in, specifically that part of angle I. I know that this is a right triangle, and the vertex angle at F is 90 degrees. I also know one of the interior angles of that triangle, which is 60 degrees. To complete the triangle and make 180 degrees, 60 plus the missing angle here must add up to 90. So this must be 30 degrees. 60 and 30 makes 90, and then the additional 90 degrees at vertex F makes 180.